Hello everyone, let's start. This is Jia Quan, the co-dev in Automata. Welcome to today's Automata Bounty track as part of the AVSthon. And we encourage all developers in AVSthon can participate this TE journey. And later I will share some details about this bounty. And at first, about Automata, we are building a modular attestation layer that establishes trust in computing machines by verifying their authority on-chain. And the TE coprocessors are one of the biggest unlock for open invocation in EigenLayer AVS landscapes. And currently, our multiple AVS on EigenLayer supports both score and linear networks. And there are around 70 operators are joining our AVS. And we are also extending our impact to other rollups networks. Besides working with the Workcoin Foundation, we are trying to use the TE-compatible GPUs, the NVIDIA H100, to extend the influence of the TE technology stacks. And in this AVSthon, Automata released a 60K ATA boundary. Here is a task that we are looking for to develop AVS that use either the Automata SGS SDK or the Automata Decap v4 libraries. Later, I will share more details about these two tools and how they work. The Automata SGS SDK is a Rust indentation that allowed developers to build applications that run within Intel SGS enclave, and it is supported by the Cargo, and it is focused on being user-friendly, fast, and efficient tools. And we build such SDK to accommodate a broad user base, including the industry projects. Developers who are interested to build with the TEs, but might not have much more knowledge or don't know how to start, and who often have conflicting requirements and domain knowledge. So within this SGS SDK, it will simplify your TE journey, and the developers can focus on what they need to do in the applications. And natively, by leveraging this SGS SDK, you will have a entire TE environment to be executed inside your applications. And for the second one, the Decap v4 libraries, it provides a unified interface to verify the Intel SGS or TDS attestations on chain, which means if you are very familiar with the TE stacks, especially focusing on the Intel TDS or some other TE terminology, you can still use this Decap v4 libraries to perform on-chain attestation with smoothly. And part of his design is the on-chain PCS, a decentralized repository to manage, store, and reuse the Intel Decap collaterals. And it also supports two verification modes for the Intel Decap attestation, the native way and the proof aggregation way, by using the RISC-0 to speed up and to optimize the gas cost on-chain. And it would directly use the code verification on-chain for some economic security. And here is the guidelines that we are looking for these AVSthons. For your AVS, it should use the TEs in a novel way, which means it is meaningful to integrate with TE inside your application to enhance your whole AVS secure level or the secure guarantee that you give your users. Instead of focusing on the TE to the AVS, we want to see a init possible requirement to and apply it. So we will consider the ideas that how you put the TE inside your AVS and how it works. And in your project, you should have a clear structure of the proposal on how the TE works in AVS as a POC solution. And last but not least, it should benefit the ecosystem at large, and the key components should be open source. And then everyone in AVS or EigenLayer can share all the technology that you have for these AVSthons. And here are some useful links and resources that you can find on how to use the TE, especially focusing on the Automata SJS SDK and the decap v4 library that I mentioned before. All these repos are open source, and feel free to try it out and drop any questions in either Discord or Telegram if you meet during your development. And we are good to answer your questions and get to help you to figure out how to integrate the TE into your applications. Yeah. I think so much for the sharing. Any questions? If not, then we will see how you can build the AVS in the TE to see how the things will work. Yeah, thank you for everyone.